All right, we got our VI here for homework 2 on LabVIEW. As you can see, we'll start with the biggest structure, which is the while loop. Our input is defined as the counter iteration. You can see in blue here. I will also say that I've branched this off into the 3 different functions. X is basically I here. Uh, The expression node is probably the fastest and most convenient way to use I. Just is a lot faster, a lot better, cleaner and sleeker looking since it's just a one input, one output function. Then you can see for my own convenience, I've included indicators spurring off of the output of these functions. It's just to verify that I'm getting the right numbers. And of course, we've got our 3 waveform charts, M1, M2, M3. And I'll show you them on the front panel real quick. M1, M2, M3. You can see this one's already been running. We'll resume it here in a minute. Also spurring off of these inputs, we have our inputs into the sub VIs. You can tell I have 2 of them. This is just so that we can plot both the average and the RMS outputs at the same time. You can see that for our control for the sub VI, if you want it to be an RMS, like it said per the assignment, you input a 1, that's an enumerator constant. Then we have a 0 for the enumerator constant for the average. We have an average indicator and an RMS indicator. This is just like I said for calculation verification. I have a time delay, which is not sure why that's there, but I hadn't had any issues with it so far. I've run it quite a bit. 0.25 is what I've been running with time delay, just so we can watch it populate and it's not too incredibly slow. Lastly, we have a control for the user. I'll switch over to our front panel real quick. We'll go ahead and run while I kind of walk us through. You got, like I said, M1, M2, and M3, and we have our value indicators right here. And then output over here. The way I know that this is correct is fundamentally an average absolutely can be negative. But the question is, would a RMS value ever be negative? No, you can see it goes down to 0, but it never quite passes 0. And the reason for that being anything less than 0 under a root is imaginary. So that's why you would just see the real portion of it right here. Plus your squaring values. There's no subtracting in the RMS. So it can absolutely be 0, but it won't be less than because you are squaring your outputs from M1, M2, M3. And of course, dividing by 3 and taking the square root, which actually leads me to what I'm going to show you next, which is our sub VI. Now, I don't want to open the sub VI from here. I don't really know why it doesn't like that, but essentially, when you open this file and you go to open the sub VI, it's going to search, or you open the sub VI first before this VI, it's going to search for this VI. So best rule of thumb I've learned so far in LabVIEW is just open the main VI, open the sub VI from the file explorer. It just eliminates all sorts of room for error. What I want to show you here is actually not the front panel first, but the block diagram. Just kind of walk us through. I used math inputs for these expressions rather than expression nodes. Just seemed like an easier thing to do for me, considering there are 3 inputs and not just the one like we had before. We'll take a look at our case 0, which is the average, like the assignment specified. You can see we're adding our three regular numerical inputs. Then we're dividing by 3. That's your average. And that's our 0 case. Like it said in the assignment, 1 case, however, is RMS. So we're squaring all the inputs, summing them together, dividing by 3, taking the square root. It's your RMS. Just to make sure and demonstrate that this works, let's do an easy example. Let's do 10, 20, and 30. And the input 0, so this should be average. Yes, so the average is 10, 20, and 30 is 20. It's absolutely correct. And RMS value should be slightly higher, much higher, 21.6. That's the RMS value for the 3 inputs, 10, 20, 30. That's going to conclude this video. Have a good one.